10.5 Laws of Logarithms, and there's 3 rules that you're going to have to memorize. You are going to be converting logs from a single log to 2 logs, or more, possibly. Here, when you have m times n, that means you can split up your logs and add them together and they mean the same thing. When you're dividing m over n, that would be like subtracting. So multiplying, you're adding, division, you're subtracting. And then there's a third law that says whenever you have a power, you can put that in front of your logarithm. And you're going to use these 3 rules. And sometimes it wants you to state the logarithm as a single logarithm, and then sometimes it wants you to break it up into 2 parts. Here it's giving you, we're going to look at this problem right here, the log written as a single logarithm, and it wants you to write it in terms of m and n, so it wants you to split it up. So I'm going to go ahead, since you're multiplying these, I'm going to use the first law that says when you're multiplying you can split them up and add them. And this is it's called log base 6 m squared n to the third. So this is base 6, and your base shouldn't change. It's still m squared plus log base 6 n to the third. Now, whenever you have a power, you need to put that in the front because of rule 3. So I can make this 2 log base 6m plus 3 log base 6n. And that would be your final answer, and you would have split up the logarithms. Example number 2, it says express log base 2 of the square root of m over n to the 5th power in terms of log base 2m and log base 2n. So you're going to split this up. First of all, the first thing I would do is I would try to get rid of this square root. So you should understand that from previous chapters that if you write m divided by n to the 5th power, you can take this whole thing to the 1/2, because this is a 1 on the outside and then this is a 2 because you have the square root. So now you have m over n to the 5th to the 1/2, and I would go ahead and move that in the front. So I'm going to have 1/2 log base 2 m over n to the 5th power. And it's still to the 1/2 is still there, so this is just the power of 1. But I would leave it alone. I wouldn't write it like that because it's easier if you just understand that it's to the 1. So now whenever you have division, you can use law 2, which says that you can split these up by subtraction. So division means you subtract them. And you have a power here, so you need to get rid of that power, so you have to put it in front of the log. And if you notice, I put my log base 2m minus 5 log base 2n in parentheses, because you need to understand that the 1/2 was to the m and the n, so you have to include it for both parts. You want to make sure you put it in parentheses so you know that it's not just to the m, it's also to the n as well. And you split up, you don't have any more exponents, so you are done. Example number 3, the direction will say to express as a single logarithm. This means that you're going to work backwards. This time, it's going to give you your logs, and they're already split up into 2, and it's or more sometimes, and it wants you to write it as a single logarithm. So you have to work backwards. So first thing I would get rid of is any numbers that were in front of the logs, and I would make those exponents. And I'm just using law 3. I'm going to go back up here to show you, and you're working from over here to backwards. So you'll be looking at the right hand side going to the left. So converting backwards. So I'm going to put the 3 up here, so I'm going to have log base 10 of p plus log base 10 of q to the 3rd. And then since you're adding, we know that when we're adding, that means that we can multiply the p and the q to the 3rd together to write it as a single logarithm. And that would be your answer for A. B, it gives you 4 log base 10 p minus 2 log base 10 of q. So again, I tell you to get rid of your exponents, or your numbers in the front, and make them exponents. And then now, since you are subtracting, you know that subtraction is the same as division. So I'm going to do p to the 4th divided by q squared. And this would be your answer written as a single logarithm. Example number 4, it gives you log base 10 of 2, and that equals 0.30. It's going to tell you, and whenever you have anything in base 10, that's what you can use the log, and you have that log button in your calculator, and you can only use that log button when you have a base 10. So it's telling you if you find the log of 2 in your calculator, it's 0.3, and the log base 10 of 3 equals 0.48. And again, that only works if it's in base 10. If it's in any other kind of base, it won't work out for you. So it wants you to find the following, and you are going to get a decimal answer, and it's log base 10 of 18. And it gives you these to work off of. So you're going to look at 18, and you need to understand that you want to use 2 and 3. So when it's possible, so for example, we know that 2 times 9 is 18, but that doesn't help me because 9 isn't one of the choices. The only log base 2 and log base 3. So that doesn't work. But I know that 2 times, and I know that 3 times 3 is 9. So I could have 2 times 3 to give me 18. So what I'll do is I'm going to use these numbers, and I'm going to make 2 different logs. I'm going to have log base 10 of 2 plus, now I'm going to do log base 10 of 3 squared, and the reason I added them was because here I multiplied. So remember, when you're multiplying, that's the same thing as adding when you're talking talking about in terms of logs. So here we have, one more time, I have to use the numbers 2 and 3, and this is where your number sense comes in. And you have to look and you go, okay, I know that 2 times 9 is 18, but 9 wasn't one of my log choices. But I can make it 3 squared, and I know that that's 9. So I know that 2 times 3 squared is 18. So since I multiplied, I split up my logs and I'm adding them. And I made it 3 to the second power, which we know if we're writing these as two different logs, we need to put the 2 into the front, right? So I have 2 log base 10 of 3. And so now I could figure out what these are, because I know that log base 10 of 2 is 0.30, and I know that log base 10 of 3 is 0.48, but I gotta multiply it by the 2 that was in the front, right? This guy. So again, I just used what I knew. Log base 10 of 2 was 0.3, log base 10 of 3 was 0.48, and since it had a 2 in the front, I have to multiply it by 2. So when I do 0.3 plus 0.48 times 2, I get 1.26, and that is my answer. Let's try another one. Let's do B. I have log base 10 of 20 divided by 3. Okay? So you know whenever you're dividing that you're going to eventually subtract your logs. But first, I know that 3 works because 3 was one of my log choices, but I have to look at 20. And I know that 2 times 10 is 20, and I still can divide that by 3. And there's a special rule with 10. Whenever you have log base 10 of 10, your answer is 1. And that's something you have to memorize. I know it's on the final. I know it's on your test. So whenever you see log base 10 of 10, you automatically know that that's your answer is 1. So, excuse me, technically whenever you're given a couple choices, if it were me, so I don't forget, I would also write that I know that for sure log base 10 of 10 is 1. It always will be. So we're looking here, so 10 was an option, so that's good. So I have a 2, a 10, and a 3, and those are 3 choices that I have for logs. So we know that I can make this log base 10 of 2. When you're multiplying, you're adding, so I can make this log base 10 of 10. And then we're going to divide, so when you divide, you subtract log base 10 of 3. And now I have my log written out, and so I can go ahead and plug in what I know. I know that log base 10 of 2 is 0.30, log base 10 of 10 is 1, and log base 10 of 3 is 0.48. When you do the math, you end up getting 0.82, and this is your answer. Let's do C. I have log base 10 of 5. This one's kind of tricky. This one you have to somehow use, the numbers 2, 3, and 10 still, okay? So remember, we got 2, 3, and 10. So we have to use these numbers to somehow get 5. So, well, I know that 10 divided by 2 is 5. So I'm going to have log base 10 of 10 over 2, which I know I can write that as log base 10 of 10 minus log base 10 of 2, because division means that you are subtracting. So we know that this is 1 and log base 10 of 2 is 0.3, so you will get 0.70. Let's do one more like this. Log base going to make this an exponent. So I'm going to have log base 10. I still have 1, but let's make this 2 to the 1/3. And if I want to bring this up here, I can make this log base 10 to 2 to the negative 1/3. And so now I've kind of gotten rid of my fraction here, and I can look at this as an exponent. So whenever you have an exponent, you can just move that to the front. So I'm going to make that negative 1/3 log base 10 of 2. And now I have my log base 10 of 2, which is one of my answers. I can do 10, 2, or 3. Well, 2, we know log base 10 of 2 was 0.3. And I can multiply that by negative 1/3. And when I do that, I get negative 0.10. So whenever you have a square root, you always want to make it an exponent. And if you can, get rid of your, if you have an exponent, I would get rid of your fraction if possible. It makes it easier to solve. Let's do one more and then we'll be done. Example number 5. Solve log base 3 of x plus log base 3 of x minus 6 equals 3, and you are solving for x. Okay, so here, when you have log base 3 of x, and you notice these all have the same logs, so whenever you're multiplying, you can turn this into multiplication, or whenever you're adding, I'm sorry, I'm saying this wrong. Whenever you're adding, you can multiply them, right? So we're going to make this a single logarithm so that we could solve for x. So here's your addition sign. So you're going to have log base 3, and you're going to have x times x minus 6 equals 3. And I can do that because it's addition. So I can multiply them, make it 1 log. And then I can go ahead and distribute that x, and x times x is x squared, and x times negative 6 is negative 6x equals 3.